Yes, sure. Shazar, this time you will start with the introduction part and with the questions part.
All right. Who is the candidate? Aisha, I believe. I think she is Aisha. Okay. Aisha, can you hear me?
Yes, I can hear
Can you
you.
hear me? Perfect.
Yes, I can hear you.
Mubarak, good day. How are you?
I'm good, alhamdulillah. How are you?
I'm well. Thank you so much for asking. So we are here for a little activity which is supposed to be your, conducting a technical interview. And so with me is Mr. Shahzaib Hassan, who is a senior process engineer at Polymers and Chemicals, and he has an overall experience of refinery operations as well as petrochemical facility at Anglo Polymers. With us is Mr. Bernard Osseron, who is the CEO of Apple Visions from Uganda. He has joined in from there as well. And myself, Shazar, and I'm working as a process engineer at Anglo Polymers and Chemicals for the PVC plants. So this is as far as our brief introductions is concerned. So can you tell me about yourself? Which semester are you studying? What are you have been your majors, and a little bit about your hobbies?
Okay. So first of all, as you already know, that my name is Aisha Ellaf, and currently I'm a pioneer student of bachelor's in chemical engineering from NEDUET University, and basically with a CGPA of 3.907. So my key skills basically include team management and critical thinking, innovative thinking, and teamwork and management skills and decision-making skills. And basically I have attained all these skills by working in different group projects and different group assignments which are all given to us in our university, and different mini projects. And also I have done 2 successful internship projects, one at the denim industry and the other one at the pharmaceutical industry. One was basically the optimization of different processes, that is the washing processes in the denim industry, and the other one was basically the conversion of a batch tablet coating machine into a continuous tablet coating machine. And I bring to you all of these skills today, and I guarantee to whichever company I'm like giving the interview, I guarantee that company that I will provide you with much more profit and much more growth on the basis of these skills. And the reason why I am applying to a particular industry and etc. is basically that I want to grow in a growing environment, and I want to improve more, and I want to bring all of these skills and my previous education and experience into application. So that's all from my side.
That's pretty powerful. Excellent work. You just mentioned out that critical thinking, analytical thinking, and teamwork has been your attributes, right?
Yes.
Can you give me one example of applying your critical thinking? Just an example of it.
Only critical thinking, or the other one that you said as well?
Just the critical thinking.
Okay, critical thinking. So basically it is that whenever a project or whenever a group assignment is basically assigned to us, so whatever you have to do is that you have to obviously think out of the box and come up with a different kind of idea that your assignment or your group project is different from the other ones, right? So whenever like in different subjects whenever we are assigned a projects so always my work the group which I am of which I'm a leader, my work is alhamdulillah always different, and I always come up with like a different idea on the basis of like research work etc. And that idea which has all kinds of aspects, like which also consists of our technical skills, and in which different software skills are also incorporated, and that's how I apply the critical thinking.
Are you a position holder of your batch?
Yeah, I am.
Okay. So what are the different areas of chemical engineering that interest you the most?
That interests me the most are basically subject wise, my favorite subject is fluid mechanics, and the areas that I'm more interested like currently right now is basically the designing of different equipments.
All right, all right, all right. So fluid mechanics stands out, right?
Yeah, it does.
Okay. So if I ask you, what's the difference between for example, if I ask you, I've asked this question to another candidate as well. If I ask you exactly the same question, for example, if I have a scenario in which I'm supposed to transfer a fluid from one tank to another, and the service is, let's say, for example, for the sake of simplicity, is just water at an ambient temperature. So if I'm handling a water with what would be your strategy or the consideration that you would take if I ask you to utilize a higher capacity firm, a higher capacity pump, in contrast to like utilizing two different pumps, what would be your considerations in it?
If you would ask me to use a higher capacity pump
Capacity
rather than the
pump,
two, yeah,
two pumps,
rather
like
than the two different.
utilizing, yeah, for
Okay.
example.
Oh, so basically, we know that the basic two classes are basically the kinetic pumps and the positive displacement pumps, right? So you use like a positive displacement pumps for higher head and lower capacity or lower flow rates, whereas you use kinetic pumps for higher flow rates or higher capacity and lower head. So if you like provide me this scenario and you want like a higher capacity one, so it would be one of the kinetic pumps, the centrifugal pump, I guess. Yes.
And if I'm only restricted to you to utilize the centrifugal pumps and I'm not supposed to go for the reciprocating dice pumps, then can I use like two different pumps in contrast to a higher capacity pump, an increased capacity pump?
Yes, it depends upon like yes, you can surely use that, because if you are like using in terms of like in terms of series, if you are using in terms of series, and it also depends upon you have to do the budgeting and all the cost analysis, etc., of of one single higher capacity pump and the use of the other two pumps. So whatever suits you according to the cost analysis as well, and according to the availability of the equipment as well, you can use among those. You can use among the two options.
Is it a good practice to place an isolation valve at the upstream of a pump?
To place a which valve?
Is it a good practice to install an isolating valve at the suction of the pump?
At the suction side of the pump.
Or rather, we should use any other component.
Well, basically, there are like.
You said the design aspect was, was a thing that fascinates you, right? So just from that aspect.
Yeah. Okay. 1 second, please.
Sure. Take your time. Take your time.
I don't think so that it's good to apply some kind of valve at the suction side, because bilkul as near to the suction side, because suction side already there are a lot of problems, like there's a pressure drop, and then the problem of the corrosion, etc. They are also at that point, at that side as well. So if the valve is also there, so maybe there can be like problems with the valve as well.
Okay, and what is meant by the term flow turbulence?
Flow turbulence.
Yeah.
Basically, there are like two types of flows. One is the laminar flow, the other one is the turbulent flow. So the turbulent flow are basically when there are like small types of eddies created in the whole massive flow. So, and that type of flow is basically not suitable, and it is not like it is not wanted usually, the turbulent flow or the flow turbulence.
And
it is taken care that it must be decreased. It must be in decreased amount.
Right. And one more thing, what's a pump shut-off? What is called a shut-off condition of a pump?
Shut-off.
What is meant by it? Yeah, what is meant by it? Not the head, just the condition. I'm asking about the condition, not the head.
It was something like there was an experiment, like let's suppose there is a centrifugal pump, and what happens is that first of all, the centrifugal pump is basically completely closed, and the flow is the outlet valve of the centrifugal pump is completely closed, and water is from the inlet is completely coming and applying the pressure on the closing side. Like if you have like a shut off something, if you have some valve with the help of which you have like shut off the outlet flow. So basically what happens is that that the valve is open in like lower amounts, and it's like it's open like first 10%, 20%, 30%, etc. And then there's a curve is basically generated. First of all, the head is actually the max head at that point is maximum, whereas the flow rate at that point is minimum. And then when at the end, when the outlet valve is completely open, then the head becomes like minimum, and the flow rate becomes maximum. So I actually don't remember which point was the shut off point. I guess the last point.
Yeah, and just the last question to come before I conclude from my end: how is this like different from the churning of a pump, or the churn off of a pump, centrifugal pump? How is this condition different to that?
Churn off, like CHURN.
Warren, yeah, absolutely.
I don't know about that term. Sorry.
So you don't have. And would there be any integrity loss or loss of mechanical integrity to the pump if I'm continuously circulating or constantly operating my pump, my centrifugal pump on like shut off condition? Would that lead to any loss of mechanical integrity as far as my pump is concerned?
Like you are continuously like operating your pumps at higher flow rates. That's what you're saying, or higher head.
I'm operating my pump on shut off condition. Would that lead to any loss of mechanical integrity to my pump?
Yes, because I guess your pump is because basically a centrifugal pump basically has an impeller, which is like always splashing your fluid or your liquid. So if you are continuously gonna make it like work on such conditions, then there will be some mechanical or material losses as well. Sorry, mechanical integrity losses.
That might be termed as churn.
Okay.
Okay, but anyways, so moving on to Mr. Burnett and Mr. Shazib Hassan for the rest, for asking you for any further questions. Thank you from my side, Aisha.
You're welcome.
Good evening, Aisha.
Good evening, sir.
My name is Bernard. I'm a chemical engineer by profession, and I'm also the founder and managing director of Apple Vision Limited, which is a consulting and engineering company in Uganda. I worked in the pharmaceutical manufacturing industry for 6 years before I moved to the service industry. I'm really very excited by what you've just talked about, and you've confirmed to me that we go to school to get knowledge, skills, and then we apply them. I've liked the way you've articulated that information. Now, I have a few questions that I would like to discuss with you. I don't want to say I'm going to ask you. We are going to discuss. From your introduction, you talked about team management. And that has confirmed to me that as chemical engineers, we are trained to become engineering leaders and managers, right?
Yes.
What's the difference between a leader and a manager?
The difference, according to me, between a leader and a manager is that a leader is basically quoted or is basically given the responsibility, like that you have to do this, or you have to like govern or lead a particular number of people. But a manager is, I don't think so that he is like quoted or given a particular position. He can be among the people. Because there is a quote that not a quote, but a learning that I recently learned, that you don't have to have the authority, or you don't have to become a leader in order to lead a number of people, or in order to manage a number of people. You can take that responsibility by yourself as well. So I guess that manager is that one who is not quoted or who is not given a particular responsibility. He takes that by himself. Whereas a leader is, I guess, quoted. And maybe I think I'm wrong. I'm not sure.
Why are you doubting your answer?
I am doubting my answer because
So speak.
because I think so that because both are quoted. That is the reason why you call them managers and leaders. So that's why maybe I'm wrong.
Oh, the two terms are the same.
Yeah.
Is it true? Are they the same? Is a leader a manager? Or is a manager a leader?
Yes, both of the terms are same, I guess. Yeah,
Are
I
you
conclude
sure?
them that it's same. Yes, I'm sure.
No, they are different.
Okay.
They are different. Just like you had tried to explain, you brought it right. A leader persuades the team to achieve a goal, and the leader knows how to achieve the goal and leads by an example. Okay? Unlike a manager who gives instructions that at the end of the day, we need to achieve a profit margin of 100,000 US dollars. How to achieve that is none of his business. Okay?
Okay.
So
Okay.
you explained well. So I would like to share or to understand your experience in team management. You said you worked in was it industrial training in the pharmaceutical industry?
Basically, I work in teams in both, like in the group projects in my university as well, and also in group projects in industries as well.
Okay, from the perspective of group projects that you've been engaged in, what are some of the challenges you faced in working as a group? And how did you overcome those challenges?
Okay, so basically the challenges that I usually face is that my point of view is actually quite different from that of the other team members. This is the first problem. Second problem is basically that due to some tragedies or due to some problems, sometimes I don't get such members that are exactly according to my pace or according to the requirements that I want them to be. These are the two basic problems. Like, they don't work according to my time management. They don't work according to what I tell them. So I managed the two things in such a way that first of all, when it was very initial phase and when I did not know about anything, at that times I had problems. But then later on, I understand that if they are not trying to understand my perspective, I have to change the way that I am explaining them things, because maybe there's something wrong in the way that I'm explaining to them. That's why they're not understanding. So I basically made my way much more simpler and much more easier. And I used to use, maybe I'm doing it right now as well, but I used to use long sentences. So, and the other person was like completely confused or roaming in what I was telling to him or her. But then I made my sentences concise and I made them cut shorter. And then the other point was that I started to observe and I started to listen more to others as well. That helped me to communicate and to bring on my perspective and also to understand their perspective as well. The other thing was that as I already told, that I do not usually get good members due to some things. So I tell them that these are my requirements and these are what I want from you. And then I give them a whole of plan that you can do this, and with the help of this type of time management, this type of planning and doing like when you provide others the whole way, the whole path very clearly, then they can easily walk on that. So that is how I manage those types of people who are not that good in nor technically nor any other. So not from any other aspect. So I provide them things and provide them details, complete refined details that helps them a lot.
That's so wonderful. Now, in the pharmaceutical, which kind of projects did you work on in the pharmaceutical industry?
In the pharmaceutical industry?
Yes, which project did you work on?
Okay, so in the pharmaceutical industry, it was that they had a tablet coating machine, and it was a batch reactor or a batch machine. So we had to convert that batch tablet coating machine into a continuous tablet coating machine. And we did that with the help of two other mechanical engineers. They worked on SolidWorks, and we were me and another one of my companions. We basically performed all the calculations and all the flow-wise calculations, etc.
Which problem were you solving?
Which problem?
Oh, yes, which problem were you solving? Why did you take up that project to convert the batch reactor to a continuous reactor?
Oh, okay. So what was the problem statement? So basically, we went on the internship or to the industry, and they were basically facing this problem that in the pharmaceutical industry, first when the tablet is first made when the punching of the tablet is done, it is then brought in. It is then like put into buckets, and from the buckets it is then brought to the coating area. So if in the pharmaceutical industry, you can obviously, what they do is that they minimize the contact with the tablets, and they minimize the contact with the tablets. One was this thing. So in order to minimize the contact with the tablets, what had to be done was that when the tablets are made, and when the tablets are punched, and when they are shaped, they must be directly brought into the coating machine rather than being brought by hand, being first put into the buckets and then brought from the buckets to the machine. So there had to be a conveyor, or there had to be a covered conveyor or covered sliding something. That is the reason why the batch had to be converted to continuous. The other reason was the time and was the cost. We know that when the process is done in the continuous reactors or continuous machines, then the time is less as compared to that of the batch one, and the cost is also less, and the labor work or the amount of labor that is used, that was also less in the continuous one. That is the reason why they had to have the continuous one.
As a chemical engineer, how did you approach that problem? How did you convince the management to accept you to undertake that project? And how did you arrive at the solution?
Okay, so first of all, we were very much, this question has basically two parts. So first part of your question is, the answer to that is, it's not like a final year project that you have to make a proposal and then you have to bring it up to the management and they will accept it. It wasn't like that. It was that on our summers, in our summers, we went to the industry, and that industry had this problem, so they gave us this problem by themselves. So, and the second answer is basically that, first of all, we did not even have any idea that from where should we start. So first we did a whole scenario of the whole of the industry. We first understood all of the processes. Then we spent 2 to 3 days in the coating area, and then we realized that how should we start our project. This much was already understood, that there is a need of a conveyor so that you can directly bring the tablets from the punching to the coating site. This was already understood, but the problem was how to develop the machine, how to develop the rotation time. Should it be a linear one, or should it be a screw motion? Should it have a screw motion, etc. So then what we did was that we first got the data of the tablets, that what is the size of the tablets, what is the thickness of the coating, and how much amount of coat must be required by one tablet, etc. We got all that data, and with the help of the formulas, that with the help of different formulas of the flow, of the weight, etc., we realized that in a particular amount of time, how much tablets must be coated, or what is the requirement according to them. And then what should be the area of the machine, of the tablet coating machine, what should be the time, what should be the rotation, etc. So with the help of, we required a lot of help of the mechanical engineers as well. But from our side, the study was based on the data collected about the thickness, about the time, about the weight. Basically, the work was basically on the weight. on the weight of the tablet, like before coating and after coating and etc. The equations were based on that.
Before proceeding with that project, did you do some feasibility study or analysis?
Some feasibility study or the analysis of the already going project, already going process?
You had to do, there was that old process that you wanted to change. And then the new one that you were proposing. Did you do some feasibility analysis for the two?
Feasibility analysis, well, it was actually a project that we had to change. Well, the thing was already there, but we had to change because we had to change the aspects of the thing. And we did a scenario. Yes, a scenario was done in order to collect the data. Sorry, the feasibility scenario.
What I'm
like
trying to
saying,
mean, okay. For the new project that you did you do some feasibility study on it to check if it was better than the old one?
We did not perform the feasibility study like before, but we did the validation of our project afterwards by running it on like SolidWorks. There's a software SolidWorks, so we ran our equipment on the SolidWorks and we observed that is it feasible or not, but we did not perform it before. We did the validation part, but not the feasibility.
Because I'm wondering, how did you gain the confidence that the new proposed project would be better than the old one from an economic perspective?
So basically, the confidence was actually gained because of the supervisor that was already working there, already working in the industry. He basically provided us that you have to make a continuous machine rather than the batch one. So the confidence was basically provided by him.
Okay. Now, while executing that project, which chemical engineering skills did you apply to arrive to that solution?
The chemical engineering skills that we applied was, I don't remember the exact equations, but the most of the work was basically performed on the weight analysis and the movement of the sprayed tablets all around the coating drum. So basically the equations of the weight and the equations of the flow were basically applied.
Yes, exactly. That's what I wanted to hear. Now, you know, chemical engineers, they are trained as problem solvers. They are able to identify a problem and then develop solutions. And in the process, they do modeling. After modeling, they do simulation. Okay? And
Yes.
then eventually, when they get the solution, they can go ahead to optimize. Did you do any of this?
We did the problem identification part. Then we did the simulation part. We did not perform the optimization part. Optimization is basically then performed that you already have a process that is like working, and then you perform the optimization, you cut down the parameters so that the already process is much more efficient in all the aspects about in accordance with the energy, in accordance with the cost, etc. So we did perform it like no, we didn't perform the optimization part, but the rest of the steps we did perform.
What happened during modeling?
During modeling, during modeling, it was that we had a number of structures. We had like, should we go with the screw type of the drum? Should we go with such a drum that does not has a screw motion in it, or the screw conveyor, or the screws like you know, with the walls of the drum? Should there be screws or should there not be screws? So we performed it like on the SolidWorks. We used like first we used a plain drum, and then we used to change the diameters of the drum. We used to change the length of the drum. We used to change the time of the motion of the drum. So we used to see all of these changes, basically which values of these parameters or of these conditions are most suitable for us. So that is how we perform modeling. We didn't do it like on AIChE.
Meaning at modeling, you developed some mathematical equations that represented the actual process.
The thing which I was telling you, we basically developed some structures as well, but according to the modeling equations, we did modeling according to the equations as well, which I already told about the weight ones and about the flow ones, about the time ones.
Okay, so what was the outcome of that project?
The outcome of the project was basically a machine. Okay. So a machine in which there was a machine in which from the inlet there was a conveyor, from the outlet there was a conveyor. The machine had a rotation. The machine had screws in its walls, and then the goal that they provided that this much amount of the tablets must be coated in this much time. We basically did a little much above that so that the difference can be seen. And safety was also safety analysis was also done on that. And the outcome wasn't a physical machine. It was a machine on the SolidWorks. It wasn't a physical created machine.
Oh, did management accept to take? Yes.
Bernard, how many minutes you will take further?
Like 2.
Okay, thank you.
Please. Did management accept to implement this new solution that you provided?
The management in front of us, the time at which we presented a whole of the presentation, at the end they said in front of us that they will implement that, and they were like, okay, this is achievable, and this is like this is realistic, and in front of us they accepted that they will implement it. But right now I am not aware that is it implemented or not. But we did write a paper on it as well.
From this interaction, I've realized you are good at identifying and providing solutions to problems. But now today, as I wonder, there is this problem that is affecting the entire world, the problem of climate change. And from an engineering perspective, industrial processes that are producing some of these greenhouse gases are a contributing factor. Is that true? As a chemical engineer, what do you think we need to do to reduce?
What I think that we should do, basically my FIV project that was, I guess, already told to you by one of the companions. Our FIV project is also based on these types of emissions. Like it's basically a carbon dioxide capture from the natural gas, right? So we want to decrease the amount of carbon dioxide that is already present in the found out natural gas. So as an engineer, what we should do is that what we usually do is that our main focus or our main goal is basically most of the time just the cost, right? That the cost must be decreased. That is the job of an engineer. But it must be brought into more of action or more of application, that you are much more concerned about the environment, about the emissions as well, as much as you are concerned about the cost. So if that thing is like brought up as such a factor that is like extremely important, and that it must be brought up as a first priority, then I guess much more processes will be performed in which the emissions are reduced.
Thank you for the confidence and your experience and skills.
Okay. You're welcome.
Back to Hassan.
Hello, Aisha. Hope you are good. I will ask you quick questions. Do you have any certification at this moment, like ASPEN AIChE certification and any other softwares?
No, I don't have certification right now.
Okay, so are you willing to achieve it?
Yes, I am willing to achieve it.
Do you know AIChE software?
Yes, I know about the AIChE software.
So why don't you apply on the Tech website for the ASPEN user free certification exam, which is of 4 hours. All you need to do is to register with your name, and basically it's $250 exam, but in the promo code you will write free ACU in capital, free FREEACU. So that exam will be compensated. So I would like you to apply for that and sit an exam to achieve that certification. It's a it's an international Aspen Tech user certification.
Okay,
So
sir. I will
secondly,
surely.
do you know HAZOP?
Yes, sir. I know about the HAZOP.
So what's the basic purpose of HAZOP and why we perform it?
So basically, the basic purpose of HAZOP is that every one of us is basically, we are already always willing or going towards that we want to protect ourselves from any sort of accident or from any sort of incident. So basically, HAZOP study is basically performed so that previously you are aware about the problems that can arise due to a certain factors or due to a certain changes in your process due to the change in certain equipments. So if you are already aware of that, then you can already like find out the precautions or find out the measures that you cannot take at that particular time of accident or at that particular time of incident. So आपको पहले से जो है वो सोच के रखना पड़ता है. So that is the HAZOP study, that you first analyze the process, find out that what type of problems can arrive in the process, and you think about and you write down that what type of the measures can be taken in order to overcome those problems.
So HAZOP is performed before the project or after the project, or both?
HAZOP is basically performed after the designing of the project and before the implementation of the project, according
Not
to me.
before the design.
Design, if the process is designed, like if the process flow diagram is designed, then you are going to know that the valve is present at which point and which point must be further alarms or further NPV, etc. must be implemented at which point. So designing ke baad and before implementation.
So you are saying that when we have complete process safety information in hand, which includes PFDs, PNIDs, process design data sheets, process design and equipment design in hand, then we will go for HAZOP.
नहीं, बल्कि इसमें नहीं, but it had one point as well that when we were studying the HAZOP, so we had like two types of diagrams. In one, there wasn't NPVs, there wasn't process safety valve, there wasn't the controllers, and the other one, the controllers were there, the NPVs were there, alarms were there. So I guess before the making, I'm changing my point here. Before making the process flow diagram, before making the information flow diagram, you need to perform the HAZOP, so that तभी आप जो वो ये सारी चीजें अपनी diagrams के अंदर लेके आओगे. So it must be performed before.
I think when you said that HAZOP is being performed after the design, then it was correct, because equipment design and process design in hand, then you will go for the HAZOP.